Okay, so then we have, and then we solve for x, so I put 6 over 12 is equal to x over 4 over x. I could also do it, everybody, I could use the 1/2. So 1/2 is equal to 4 over x, so I could simplify it. So x would be equal to 8. So you could also do it this way, or you could do the cross products. Okay, so this one, same thing. So what's the scale factor? So 15 over 10, divide each by 5, and I get 3/2. Or you also could do it as 1 5/10. And then solve angle M is congruent to angle L. HM over KL is equal to HK over GH. Solve for x. So I'm going to put 12 over x is equal to 15 over 10. Again, everybody, same thing. I could put 12 over x is equal to 3/2. And so 3 times x, 12 times 2 is 24. Divide. 24 divided by 3 is 8. Okay, everybody, or you can do the cross product. So either one, do which way works for you. Same for this one, everybody. So scale factor. Okay, so this one's a little bit more confusing, but we got it. So old over new. So I'm going to get 12 over 18, which simplifies to 2/3. Okay, and then I put Q, angle Q is congruent to angle L. And then we're going to do QR over LK is equal to RP over KJ. So 12 over 18 is equal to 20 over X. Cross multiply and divide, and I get X is 30. Okay, and then for this one, scale factor, so I'm going to put 24 over 12, which simplifies to 2 over 1, which is 2. Okay, so then we're going to set it up again. So 12 over 24 is equal to X over 22. Cross multiply and divide, and I get X is 11. Okay, so now we're going to do the proof. So the proof for this, everybody, is going to be this one. Okay, so we're going to have everybody, so we're going to write our givens. Okay, so given, so DE is congruent, is parallel to AC, and that's our given. Okay, and then we also have okay, that the angles. So I have angle DAC is congruent to angle BDE. And then we also have that angle, that these pairs of angles are congruent also because the lines are parallel. So angle ACE is congruent to angle DEB. Okay, and that is because the corresponding angle theorem. Same side, skip one, everybody. Those corresponding angles are congruent. So that means that the triangles are similar. So triangle ABC is similar to triangle DBE by our angle similarity theorem. So we proved that two angles were congruent. Okay, so now we can prove. Okay, so I can go with the sides. So I'm going to go AD. Okay, so everybody, if you look up here, so AD over AB is equal to CE over CB. Okay, and that's because we know that the corresponding side lengths of similar figures are proportional. Okay, so now what I know, so I can break it down. So I know that so I can look at it and I can go CB is equal to, if you look over here, so CB is equal to CE plus EB. Okay, so plus this part. And then we have on the other part, AB is equal to AD plus DB. Okay, and that's our segment addition postulate. I think of it as we're just adding distances together. So segment addition postulate. Okay, so then we can do some substituting in. Okay, so we're going to have DB over DB plus AD is equal to EB over EB plus CE. Okay, so I did substitution. So we're substituting those in. Okay, and then we're going to rewrite it. So when I say rewrite, everybody, remember like x over x equals 1, that's what we're going to do here. I think of it as I'm taking and I'm distributing this. Okay, so we're going to put dB over dB plus AD over dB is equal to EB over EB is equal plus CE over EB. Okay, so I'm just rewriting it. And then I can simplify it, right, because we just said that dB divided by dB is going to be 1. EB divided by EB is going to be 1. So those are going to become 1. Colors, right. Okay, and so this we just simplified. And then I'm going to take and subtract 1 from each side. So I'm going to subtract 1 from each side. Okay, so everybody, so I did subtraction. So our reason is subtraction. I consolidate. So that's our subtraction property of equality. Okay, so now we have it, everybody. So we have AD over DB is equal to CE over EB. Okay, so make sure you go home and study this. You got this.